So here you have exponential function. So y is equal to 3 to the power of x. So it's not the same as 3 multiplied by x, okay? So note they're not the same, okay? So in this case it works out the very same, and use your calculator for all steps. So x equal to minus 2, you have 3 to the power of minus 2. So on your calculator, 3 to the power of minus 2 is equal to 1 over 9. So 1 over 9. So when x is minus 2, y is 1 over 9. When x is minus 1, 3 to the power of minus 1, use your calculator again. 3 to the power of minus 1 is equal to 1 over 3. 1 over 3. So minus 1 and 1 over 3. When x is 0, 3 to the power of 0 is equal to, calculator, 3 to the power of 0 is equal to 1. So 0, 1. When x is 1, 3 to the power of 1, you get 3. When x is 2, you all know 3 to the power of 2 is 3 squared, which is 9. And finally, when x is 3, 3 to the power of 3 is 27. So this is an exponential graph, which means that it grows rapidly. Okay, so there are no minuses here. So I'm going to go down as far as I can. Okay, so somewhere down here I'm going to draw my x-axis and my y-axis. Okay, so I'm going to have my x, my y. So something like so. So your x-axis, your y-axis. So on the x-axis we have minus 1 and minus 2. 1, 2 and 3 with 0 in the middle. Okay. Now, we need to get up to 27, but we also need 1 over 9 and 1 over 3. Okay, so they're quite small. Okay, so 1/9 and 1/3. So I'm going to go maybe 2, 4, 6, 8, 10. No, I won't get up. So this is going to be 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, so that's my scale, and it's going up the same amount. So it's going up 2 boxes is 3, 2 boxes is 6, and so on. Okay, so just be careful when you're plotting this. So the first one is going to go something like minus 2 and 1/9. So this is 3. So 1, 2, 3 would be somewhere here. So 1/9 will be very small. So somewhere down here. Minus 1/3 will be just a little bit bigger. So very small at the start. 0 up to 1. 1 up to 3. 2 up to 9. And 3 up to 27. So it's an unusual type of graph. It starts here small, rises up, and continues growing. Okay, so it's an exponential graph, y equal to 3 to the power of x. Okay, and it's what we call an exponential graph. But do take your time with that, okay? Now, the next one, you have y equal to 1 over 5 to the power of x. So again, when x is minus 2, you have 1 over 5 to the power of minus 2. And use your calculator for all of these. So 1 over 5 to the power of minus 2 is equal to 25. So you have minus 2 and 25. Okay. When x is minus 1, 1 over 5 to the power of minus 1 is equal to 5. So minus 1, 5. When x is 0, 1 over 5 to the power of 0 is equal to 1. So 0, 1. When x is 1, 1 over 5 to the power of 1 is 1 over 5. When x is 2, 1 over 5 to the power of 2 is equal to 1 over 25. When x is 3, 1 over 5 to the power of 3 is equal to 1 over 125. Now, just on your calculator, just so you can see, if you have 1 over 125, it's a tiny number, okay? It's tiny, alright? So just be careful here with this again. So it's a different type of graph, it's a new type of graph for you. Draw your x and your y axis again. Your x and your y. The x's are no problem. Minus 1, minus 2, 1, 2, and 3. The problem is the y's. And so I need to get up as far as 25. So again, 2, 4, 6, 8. I might get up, will I? 18, 20, no. So I'm going to go 5, 10, 15, 20, 25. Okay, so something like so. Okay, I could have spaced it out a bit more maybe. So minus 2 up to 25. Minus 1, 5. 0, 1. And everything else is going to get smaller and smaller without ever hitting 0, okay? So your graph is going to come down something like this. Now, so there's 1, and everything else then gets smaller going down, okay? So that's what your graph is going to look like. Y equal to 1 over 5 to the power of x. And again, it's an exponential graph. Be careful with axis, okay? With your axis and your scale.